Here's how I find circumcenter with a compass. Do some arcs here, rule up the intersection right there of the arcs, and that is a perpendicular bisector of one side of the triangle. Do it again on the other side. Get some arcs over here from that endpoint, do another arc there, rule up those intersections, and that's my perpendicular bisector for that side. Now where that point meets is the circumcenter. Okay, so that's what we're going to be looking at today. And I should be able to draw a circle around here, that being the center. Oops, let's try that again. Circumcenter, come on. And that gives me a circle with all the points of the triangle on it. Nice.
I'm doing finding the circumcenter, and what is the circumcenter? So the point where the three perpendicular bisectors of a triangle intersect. It also represents the center of a circle with the three given points, or the corners of the triangle, on the circumference. Okay, so let's give 3 points. Okay, so in this example, I don't even use the word circumcenter. I just say find the center of a circle with these 3 points on the circumference. And that center is the circumcenter where the perpendicular bisectors intersect. So where do we start? My first step is going to be to find the equations. Find the equations, first step, of the perpendicular bisectors. Find equations of perpendicular bisectors of, I'll just pick AB and BC. Okay, and there's quite a lot of steps in that. Once I find those equations of the perpendicular bisectors, I solve them with simultaneous equations, and the solution to that is the center of the circle. Okay, so here we are, finding the circumcenter. First up, I'm going to find the perpendicular bisector of AB. I've done this in a previous video. First step is to find the gradient of AB, which is the change in the y's, -8 minus -9, over the change in x, 0 minus 5. Okay, and I get a value for that gradient, which is -1/5. Okay, next step, I'm going to find that perpendicular gradient, because perpendicular bisector means I need the perpendicular gradient. So the perpendicular gradient of AB is what I call the opposite reciprocal, is +5. Okay, bisector means I need to find the midpoint. So the midpoint of AB is going to give me the mean average of the x, 0 plus 5, divided by 2, and the mean average of the y, -8 plus -9, divided by 2. Okay, so that midpoint is 2.5 for the x, -8.5 for the y. Okay, now I think I'm ready to get my perpendicular bisector equation using this gradient and this midpoint. Okay, and I use the point gradient form of the formula and substitute these values in for x and y, x1, y1, and this is our gradient. So y minus y1 is y plus 8.5, because minus a negative is a plus, equals my gradient 5, x minus x1, 2.5. Okay, and now what I do to clean up this equation is I expand that 5 through it, multiply it to everything inside the brackets, and I get y plus 8.5 equals 5x minus 12.5, and my last step is to subtract that 8.5 from negative 12.5, and I get a negative 21, because that's negative 12.5 minus 8.5. And that's my equation for the perpendicular bisector of AB. I'm going to do the same thing over here. Alright, same steps, same process. Gradient of BC is change in y, -9 minus that -4, -9 minus -4, over change in x, 5 minus 6, 5 minus 6. And I get -5 on the top and -1 on the bottom, and that simplifies to +5. Okay, next up, perpendicular gradient of BC, and I'm going a little bit quicker here because it's just the same thing. And okay, the perpendicular gradient is the opposite reciprocal, and that's an okay decimal. Oh, I can write that as negative 0.2 without any hassle. Next step, midpoint of BC. Again, it's the average of the x-coordinates. 5 plus 6 divided by 2 is 5.5. And the mean average of the y-coordinates. Negative 9 plus negative 4, and then halve that. And I think I get negative 6.5 for the midpoint. And finally, I didn't show the working on there like I did here, but it's the same process. Now I'm ready for the equation. Okay, using my same formula, y minus y1 is y plus 6.5 equals my perpendicular gradient. I'll leave it as a decimal. Why not? I didn't have to round that. No big deal. Times x minus my x-coordinate of the midpoint. Okay. Similar to the last one, I'm going to multiply that negative 0.2 through the brackets. Okay, and when I multiply that negative 0.2 through, I get negative 0.2x plus 1.1. Remember, that's from multiplying these two guys together. Finally, subtracting that 6.5 from 1.1 will give me my equation of the perpendicular bisector for BC. And I get negative 5.4 when I do that. Okay, so I've got my two equations for the two perpendicular bisectors, and where these two intersect is the circumcenter. So I'm going to solve these simultaneous equations, and that solution will be that point. All right, last step. Okay, let's do this. Solve for the point of intersection. They're both in y equals mx plus c form. So I'm going to set these two expressions equal to each other and solve it. So I'm going to say, okay, 5x minus 21 is going to equal negative 0.2x minus 5.4. And yes, we can do this with the graphics, but we're gonna do it without one. So first up, get the x terms on one side and the constant terms on the other. So that means this negative 0.2x is going to become positive on this side, plus 0.2x, and that negative 21 is going to be positive on this side, minus 5.4. Okay, next up, combine like terms here, and I get 5.2x equals 21 minus 5.4 is 15.6. Finally, to solve for x, going to divide by the coefficient here, 5.2, and I get a nice whole number, I think. I get a value of 3. So the x-coordinate for the circumcenter is 3. Now I'm going to take that and substitute it into one of these formulas, and that one looks a little bit better. Plugging it into there looks a little bit cleaner. And when I substitute that x value, I'll get the y-coordinate. So 5 times the value of x, which is 3, minus 21 gives me 15, take away 21, gives me negative 6. So I've got my circumcenter. It's at 3, negative 6. That is the point of intersection of the perpendicular bisectors, otherwise known as the circumcenter. Okay, and so that's how I do it algebraically, using the geometry formulas and without a compass or a graphics calculator. But doing it by a compass is pretty fun as well. Okay, good luck.